Okay, so at this point, you should have finished or been really close to finishing that practice on quotient rule you should have finished the practice on product rule on page 15. So hopefully you did that, worked on that for a little bit, and now we're going to move on to our quotient rule. So right now we have two rules, our product rule and our quotient rule. So if we look at our quotient rule examples, the first ones we're going to do kind of just like we did our product rules. We're going to expand them out and see what happens. So I'm going to expand out the top. So I have 4 x's, so I'm going to multiply x together 4 times. And I have 7 y's, so I'm going to multiply y together 7 times. All right, that's the top of the fraction. I had 4 x's and 7 y's. At the bottom, I have 3 x's and 3 y's. So I expand those out. So in our product rule, the two numbers in front, we multiply together. In our quotient rule, the quotient is like division. We're going to divide these two numbers. So 4 divided by 2 gives me 2. Now, if we have something at the top and the bottom of a fraction, they can cancel out, or they become 1, right? If you think about 2 divided by 2, I have 2 divided by 2 is 1. If I have 32 divided by 32, I still get 1. So anytime we have something on the top and the bottom, they divide each other or they cancel each other out to give us 1. In this case, multiplying by 1 doesn't do anything for us, so we really just consider it canceling. So I have a set of x's at the top and the bottom that I can cancel, another set of x's at the top and bottom that I can cancel, and another set of x's at the top and bottom that I can cancel. So really all I'm left with is 1x at the top. And you can write the 1 here. You don't have to because it can be imaginary, but if you want to, if that feels better for you, that's totally fine. So then for y's, I have a set of y's, one at the top and the bottom that I can cancel. I have another set of y's at the top and bottom that I can cancel. And I have another set of y's at the top and bottom that I can cancel. What that leaves me is with 4 y's left at the top. So I have 4 y's left at the top. Everything else at the bottom canceled out. So the bottom of our fraction completely went away in this case. And this would be our answer. All right, so let's try this for the next one. Again, we're going to expand this out. So I've got 9. I have 2 r's, so r and r. I have 6 s's, 2, 3, 4, 5, 6. And then at the bottom, I have 3. I have 5 r's, 2, 4, 5, and I have 3 s's. Okay. Again, I'm going to take these numbers in the front and divide them. We divide those coefficients. So 9 divided by 3 is 3. Then I'm going to pair up and cross out anything the top and the bottom have in common. So there's a pair of r's I can cancel. There's another pair of r's I can cancel. There's no r's left at the top, so that means that there are 3 extra r's at the bottom. And they're going to stay at the bottom because that's where they're left. Then for s's, I have a pair of s's at the bottom I can cancel, a pair of s's at the top and bottom, a pair of s's at the top and bottom. So that leaves me 3 s's at the top of the fraction left. So if you notice, right, the first one we had 4 at the top, 3 at the bottom, and that left us with 1 extra. Then the other one we had 7 at the top, 3 at the bottom, that leaves me with 4 extra. So the pattern in this one is that we subtract the exponents. And we always subtract top minus bottom. So we subtract the top number minus the bottom number. It also can be easy to remember whichever number is the biggest one is where the remainder is left. So for instance here, that r to the 5th is bigger down here. So that means what's the extra stuff left between the two of them is left at the bottom. Right? If this S is bigger at the top, 6 is bigger than 3. So all your extra S's get left at the top. So that's another way of remembering where the letter goes. So our quotient rule says when dividing, again, we keep the base and subtract the exponents. Okay, so pause the video, make sure you're caught up with the notes, and then we'll go over some examples together. So looking at the first one, just like we did before, we multiplied those exponents, or we multiplied those coefficients. This one we're going to divide the coefficients or reduce. Some of them won't divide nicely, but they can reduce. And then we'll go ahead and subtract our exponents. So while it's nice visually to write it all out every time and cross out the top and the bottom, and you can do that, it's just more time consuming than using our product rule. So if we look at number 1, first we're going to divide 12 divided by 4. So 12 divided by 4 would give me 3. So it's going to be my coefficient. So now I have 1m. Remember, that's an imaginary 1 if there's not a number there. There's 1m at the top, and there's 4 m's at the bottom. So now if we think about 4 minus 1 is 3, that means there are 3 extra m's at the bottom of the fraction. Normally we subtract 1 minus 4, but that's going to give us a negative 3. And at this point, we don't know what to do with negative. So we're not going to worry about that yet. We just know that there are more m's at the bottom than there are at the top. So our m's are going to go to the bottom. For n, there are more n's at the top. So our extra n's, right? If I do 5 minus 3, that gives me 2. So that means I'm going to have 2 extra n's once I'm done dividing. All right, looking at number 2. First, if we take our leading coefficients, I've got negative 5 over 25. Negative 5 divided by 25 is not a pretty number. All right, that's not a whole number. So I can't divide, but I can reduce this fraction. I can divide the top and the bottom by 5, leaving me with negative 1/5. And then I've at least reduced my fraction. So now for my x's, there are more x's at the top, right? 8 is bigger than 3, so my answer for x is going to be at the top. So then when I subtract 8 minus 3, I get 5. So that means I have 5 x's left. Y is also bigger at the top, so I have 3 minus 2, which gives me 1. So my answer here, my x and y's go on top, but that 5 still stayed at the bottom because we're reducing that fraction. All right, so looking at our next one, we divide our coefficients first. So 14 divided by negative 7. So if I do 14 divided by negative 7, I get negative 2. That's a nice whole number. If I wanted to write this as negative 2 over 1, I could. Don't have to, but if that feels more comfortable to you, that's fine. So then I have more r's at the top than the bottom. So my answer for r is going to be at the top. And then if I subtract 9 minus 7, I get 2. And then there are more s's at the top than there are at the bottom, right? There are 11 up here and only 2 down here. So all my extra s's are going to be at the top. And 11 minus 2 would give me 9. So we can leave that 1 at the bottom. You can also just write it like this. Since everything is at the top of your fraction, you don't need the 1 at the bottom. But you can have it if that makes you feel more comfortable when you're simplifying. All right, so from here, we can get a little division practice on page 13. So exactly what we just did, we're going to do on this page. So let's do a couple together just to make sure we're feeling comfortable. I'm just going to do this middle row right here, and then you can spend the rest of the time finishing this page. Know that only to 15, these are your division ones, and then this is our multiplying, meaning going back to the rule we did before this. So going back to adding the exponents together rather than subtracting the exponents. So looking at number 7, I'm going to do my exponent or my coefficients first. Negative 12 divided by 4 gives me negative 3. Then I'm going to subtract for k, right? K is bigger at the top than it is the bottom. So at the top, I'm going to have a k. 10 minus 2 would give me 8. So I have k to the 8th. Then for m is bigger at the top. 7 is bigger than 3. So m will stay at the top. 7 minus 3 gives me 4. And then for n is also bigger at the top. 6 minus 5 gives me 1. So that would be my final answer. All right, so if we look at number 8, number 8 doesn't have any coefficients in the front, so we don't have to worry about dividing first. So we're just going to go straight into subtracting our exponents. So I have x, there's more x's at the top. There are 12 x's at the top, only 8 at the bottom, so x will stay at the top. 12 minus 8 would give me 4, so I'll have x to the 4th. And then for y, 10 minus 5 would give me 5. So that would be my simplified answer. So then for number 9, we're going to divide. 12 divided by negative 3 would give me negative 4. Then I have k. Both of these have an imaginary 1 here. So I really have 1 minus 1, which is 0. I don't need to write k to the 0. I can just cross these out. I have the same number of k's at the top and the bottom. I end up with none left when I subtract, so there will be no k's in my final answer. They're just gone. And then for m, this m has an imaginary 1 here. So then if I do 3 minus 1, I have 2 left at the top. And there would be my answer. All right, so you should work on the rest of this page, practice that. So 15 and 13 should be the 2 pages that you finished today in class. Yeah, we started 15 together. If you didn't finish this, go back to this. But 15 and 13 is what you should finish today in class before you leave.